Okay, so question number 4 is to write the following ions. Okay, so let's start off with nickel 2+. So when I write down electron configurations for ions, I like to first try to find the electron configuration of the atom if it were neutral. So first, let's look up the periodic table with all of the S, P, D, and F blocks kind of organized. Okay, so the light blue columns is the S block. The green column here is the P block. The middle transition metals are the D block. And the last two rows, the lanthanides and actinides, is called the F block. So when we try to find electron configuration, we start at hydrogen and then move across the periodic table from left to right until we get to our desired element. In this case, it is nickel, which is found... Where is nickel? Here. So it has the atomic number 28. So we can also verify that the electron configuration is correct by counting out all the electrons. In nickel, there should be 28. Okay, so just as an example, for this very first atom, I'm going to show the long way to write the electron configuration. But for the rest of the questions, I'll just do it for the shorthand way. Okay, so the long way of writing a neutral nickel atom is, again, to start off at the hydrogen and write the row number, which is 1, and then you write the block number, which is S, and then how many electrons are in the orbital. So there are 2, so we have 1s2. And then we kind of go left to right to the next row. Next row is 2s2, and then jumping over, we write 2p6. Then the next row is 3s2, and then 3p6. And then we have 4s2. And then when we get to the D block, it's going to be the row number -1. So we just write 3d. And then we count up to our desired element, which is nickel. So we count 1, 2, 3, 4, 5, 6, 7, 8. And then we get 3d8. Okay, so this is for a neutral nickel atom. The question asks for nickel 2+. And typically we would take from electrons from the last orbital. But for this case, we will be taking the 2 electrons from 4s2. And this is because partially filled d orbitals are more stable. So now those 2 electrons have been taken, and we can write the new electron configuration, 3p6 and then 3d8. Okay. And then if we were to write the shorthand configuration, to do that, you would just look at the noble gas that comes before nickel. So it's argon. So we put argon in square brackets, which has the same electron configuration as this 1s2, 2s2, 2p6, 3s2, 3p6. And then we just need to write the square brackets and then 3d8. So this is the shorthand electron configuration of nickel 2+. So now let's do the same thing, but for all of them, the shorthand configuration, just to save us some time. Next, we look at cadmium 2+. So again, let's just write down the electron configuration of neutral cadmium 2+. So cadmium is found here, atomic number 48. So first I'm just going to write the noble gas that comes before it. In this case, it's krypton. I'll put that in square brackets, and then starting at row 5. Or krypton. Yeah, okay. So cadmium's right here. And we are going to write 5s2 4d10. Oh, oops. I wrote it down here. Okay, so again, when we have a filled d orbital, this is more stable than a filled s orbital. So we'll be taking 2 electrons from the s, and the electron configuration for cadmium 2+ is krypton and then 4d10. Okay, so for C, we have zirconium 3+ and zirconium 4+. So the neutral electron configuration of a zirconium ion is the krypton and then 5s2. So zirconium is right here. 5s2, 4d2. Okay, so when we have zirconium 3+, again, I'll take from the s orbital, and if we were to take away 3 electrons, we get an electron configuration of 4d1. For zirconium 4+, if we took away 4 electrons, we would get the same electron configuration as krypton. Okay, so now let's do the last question, which is part D. We have osmium 2+ and osmium 3+. So for a neutral osmium atom, it is found here at atomic number 76. So the noble gas that comes before it is xenon. So we just write xenon in square brackets. And then going down, I'm first going to fit in our F block. So if you can see here, it is inserted in between right there. So I'm just going to put my 4F14, and then I'll write down my D block. Next, 5D6, and then 6S2. So I just wrote my S block last this time, just so that it's easier to show how the electrons are taken away. So if we were to take away 2 of these electrons, again, I'll be taking from the 6s2 orbital. So our new electron configuration is xenon 4f14 5d6. And then if we were to take away 1 more electron, it would be xenon 4f14 and then 5d5. Okay, so let's see what the junior tutor said. All the given ions are transition metal ions. Transition metal ions have a unique way if it loses electrons or electron to form a bond with another atom. The outer valence electrons will be the ones responsible for interacting to form a bond, hence the ns orbital electrons. Hence, these electrons form ns orbital will be removed first before the inner electrons, which are the ones in the d orbital. For this question, I'll be using noble gas notation for electron configuration for simplicity. The ground state electron configuration of nickel is argon 3d8 4s2. When it becomes a metal ion in the form of nickel 2+, it will lose 2 electrons. The electrons in the 4s orbital will be the ones that will be given up. Hence, its electron configuration now is written as argon 3d8. For cadmium 2+, they have cadmium, the krypton 4d10 5s2. When it loses 2 electrons, it is now krypton 4d10. For the 2 zirconium ions, they have ground state electron configuration of zirconium, krypton 4d2 5s2. So notice that they write the 4d before the 5s. So you can also write it this way as well. And when it loses 3 electrons, it becomes krypton 4d1. When it loses 4 electrons, it just becomes the same electron configuration as krypton. Lastly, for osmium, the ground state is xenon 4f14 5d6 6s2. When it loses 2 electrons, it becomes xenon 4f14 5d6, and then when it loses 3 electrons, it becomes xenon 4f14 5d5. So this solution is correct.